Hello everyone, I am Saad Shahid and I welcome you to the lecture videos on the well test interpretation. And in this video what I will be discussing is the introductory topics on well test interpretation. Now what reservoir engineers need to do is basically they need to come up with a field development strategy that is optimal for a particular field, and that field development strategy is basically specific for a particular field and must be made carefully. And in order to develop a field development strategy, reservoir engineers use two models. The first one is the economic model and the second one is the reservoir model. And basically what are these two models? Is the first one the economic model. It basically takes into account present and projected economic information such as price of oil and gas, interest rate, return on investment, etc. So pretty straightforward. Basically it takes all the applications of petroleum economics, and on the basis of those applications we make up a model that we can use to develop a field development strategy. Now we move to our model of interest, that is the reservoir model. The reservoir model is used to predict the physical behavior of the field in terms of rate of production and fluid recovery for different operating conditions such as primary recovery, secondary recovery, tertiary recovery, etc. And what is interesting about the reservoir model is that in order to get realistic predictions, we need to make the reservoir model that closely represents the reservoir as it can. So this is particularly important. And then the one interesting thing regarding the reservoir model is that it is never definitive, but it must be continually adjusted as the new information becomes available when additional wells are drilled. So a reservoir model is never complete, it is continually adjusted, it is continuously improved, and on the basis of that model our field development strategy also modified. So what are the parameters that we need to construct a reservoir models? Basically we need to get information from geology, geophysics and wells, and the parameters basically we use for the construction of reservoir model are basically obtained by direct measurements on cores and cuttings and PVT samples, etc., and through the interpretation of well logs, seismic data, well test data, etc. The thing regarding well testing is that it is the only application in petroleum engineering and reservoir engineering that provides information regarding the dynamic behavior of the reservoir. Thus it is essential for every single field development strategy, every single field reservoir model. So basically what well test data may provide, it may provide information regarding permeability, initial or average reservoir pressure, near wellbore conditions such as skin or stimulation, reservoir flow behavior, reservoir size, inflow performance response, communication between wells, etc. All this information is basically depending on the design of the well test. So for a particular design out there, maybe few of the information we can get, and to get the rest of the information we need to perform a different type of test. So now what is a well test? A well test is basically a process in which we record downhole pressure response due to changes in flow rate. So what we do is that we change the flow rate by changing the choke size, and we monitor the pressure response. Therefore we are controlling the input and we are measuring the output. Why I'm using the term input and output here, you will later know in few next of the lectures, and it has significance regarding mathematical significance. And basically the response, which is a characteristic of the production history, and reservoir characteristic is basically it can be interpreted by the analysis of change in pressure delta P versus elapsed time delta T. We do this analysis by plotting a curve between delta P and delta T on log scale, some Cartesian scale. More details would follow in the next lectures, but generally we take elapsed time on the x-axis and take pressure on the y-axis. Now, well test objectives. What are the well test objectives? Basically, well test objectives are three: reservoir evaluation, reservoir management, and reservoir description. Reservoir evaluation. Basically, we need to reach a decision regarding how to produce a reservoir or whether to produce it or not. So, to reach this decision, we need information regarding the deliverability, properties, size, and one more important thing is that for this particular thing, that is the reservoir evaluation, we basically attempt to determine the reservoir conductivity, that is the KH product or the permeability thickness product, and reservoir pressure and reservoir limits. So basically and at the same time what we do is basically that we will sample the fluids and measure their physical properties. Now the KH factor basically governs how fast a fluid can flow to the well, so it is important, and it is the parameter that we need to know in order to design well spacing and the number of wells. So if the conductivity is low, we may need to evaluate the cost effectiveness of a stimulation job. The reservoir pressure basically tells us about the potential energy that a reservoir has and how long the current production can be sustained. So, and the reservoir limits, basically they enable us to determine how much reservoir fluid is present and to estimate whether the reservoir boundaries are closed or open. Now, reservoir management. Basically, during the life of a reservoir, we need to monitor its performance and well conditions. So, a well test may be used in order to determine whether a well needs a workover or a stimulation is needed, things like that. For reservoir description, basically it's all regarding the geology and geophysics. We need to construct different reservoir physical models of the reservoir, so well test data may be used. Now here I would also like to tell you the something regarding well testing and decline curve analysis. In pressure transient analysis, the pressure transient is considered to be the response of a specific flow rate history. Therefore, the input here is the specific flow rate history and the output is the pressure transient. Whereas in decline curve analysis, what we consider is that flow rate response to a specific pressure history. Now here the input is the pressure, that is we are controlling the pressure and we are measuring the flow rate response. And the process in between the input and output, that is the system, is basically the reservoir. So I can say that both the decline curve and analysis and well testing are theoretically the same thing. So this is interesting, and but for practical reasons we kind of differentiate them, because for earlier analysis, we prefer well testing because it is far easier to control the flow rate and measure pressure response than to wait than to control the pressure and wait for the flow rate to drop. So in early analysis, such as in order to investigate the near wellbore conditions, we prefer well testing, and for long term applications we basically rely on the decline curve analysis, since we are then controlling the pressure and monitoring the flow rate decline. So this was about this lecture. In the next lecture I would hopefully cover the types of well test and continue my discussion regarding the fundamentals. Here is a list of references that I used in order to make this presentation. And in the end I would like to say is thank you for your time, and please if you find any discrepancy, any mistake in any of my lectures, then please do notify me. I would appreciate it. I'm also a student, and it will help me a lot in order to clear my own understanding, as well as people who are watching this. And one more thing that I would like to mention in this particular, since it is the start of the well test analysis, is that I would try to make well test interpretation simple, but not simpler, because I believe in what Einstein said, that things should be made simple but not simpler, and well testing is not particularly very easy. So in the complex, when something is complex, is then it is complex, you have to deal with it. So thank you very much, goodbye.